All right, we are diving into a really fascinating new paper today, one that could totally change how we think about artificial intelligence and how it reasons. It's called Coconut, and it basically challenges a huge assumption that most of us have been making about how AI actually thinks. So it all boils down to this one big question. Do AIs actually need our words to think? I mean, we tend to assume that for an AI to solve a hard problem, it has to reason like we do, step by step using language. But here's the twist. What if that's not just an assumption? What if it's a limitation, a cage that we've accidentally built for them? To really get why this new idea is such a game changer, we first have to take a quick look at how things are done right now. The current standard for AI reasoning, which is completely 100% based on language. Okay, so this current method is called chain of thought, or COT for short, and you can pretty much think of it as asking an AI to show its work. Instead of just spitting out an answer, it breaks the problem down and, well, it essentially thinks out loud using plain old human language, one step at a time. And when I say thinks out loud, I mean that literally. As you can see here, the model generates one little piece of its thought, a word or a token, and then it feeds that word right back into itself as the input to generate the next one. It's this constant kind of weird cycle of speaking and then listening to itself to figure out what to do next. Yeah, but here's the problem. This whole approach, it's got some serious flaws. First, you have all this linguistic fluff, tons of words that are just there to make the sentences sound good, not for the actual logic. Second, it is incredibly inefficient. Every single one of those tokens requires a full computationally expensive run of the entire model. And maybe the biggest issue? It's rigid. Once the AI says a word, it's committed to that line of thinking, which makes it super hard to change its mind or explore other ideas. And that, right there, is where the Coconut paper comes in with a totally different idea. What if we could just free the AI from the handcuffs of human language? What if we let it think in its own native tongue? And when you see them side by side like this, whoa, the difference is just night and day. On the left, you've got that familiar, clunky, word-by-word loop of chain of thought, but on the right, you have Coconut. Instead of having to translate its internal state into a word, the model just feeds that state, this thought vector, directly back into itself. It's a seamless, silent, purely mathematical flow of thought. So the AI is no longer thinking in language space, it's thinking in vector space. And this is the model's home turf. You can think of it like a complex, multi-dimensional map where ideas and concepts exist as coordinates. By keeping its reasoning right here, it can process information way more directly, without that clumsy, slow, intermediate step of translating everything back and forth into human words. Okay, so the idea is amazing, right? But how in the world do you teach a model that's been trained on basically the entire internet's worth of text to suddenly stop using text? Well, the researchers came up with this really clever training plan to do exactly that. They don't just flip a switch, it's a gradual process. The training starts off with the normal chain of thought, but then, in stage 1, they replace just the first text step with a thought vector. In stage 2, they replace the first 2 steps. They're incrementally teaching the model to rely less on language and more on its own internal math, until finally, bam, it can solve the whole problem in this silent vector space. So does all this fancy vector thinking actually pay off? Let's look at the results, because they are pretty wild. The researchers built this new, really tough, logical reasoning dataset called PROS-QA. Now, on this dataset, the standard chain of thought method got around 77% accuracy. Coconut, on the other hand, just crushed it with an incredible 97% accuracy. And get this, look at the number of steps. It got a better score while being almost 3.5 times more efficient. So just to let that sink in, the traditional word-based AI needed, on average, almost 50 steps to solve the problem. Coconut got to a more accurate answer in just 14. This isn't just a small improvement, folks. This is a fundamental leap in performance. It's a game changer. But this is where the research goes from just being impressive to being truly mind-bending. If the AI isn't thinking in words, what exactly is going on in there? What do these thought vectors actually represent? So the researchers, being clever, they tried to decode one of these single thought vectors back into English, just a peek inside. And what they found was remarkable. It didn't map to just one word. Instead, it was like a superposition of multiple concepts, all at once. So for this one math problem, a single vector was simultaneously encoding the idea of 180 and the idea of 9, Two completely different, but valid, paths the calculation could take next.
So what does that mean? It means the AI is no longer forced down one single path. As the authors put it can explore multiple alternatives at the same time. Instead of following one narrow trail of logic, it's conducting a broad search, holding parallel ideas in its mind all at once, and only collapsing them into a single answer at the very end. That's something our brains just can't really do.
But this incredible new power also comes with a really profound question. If an AI's thought process is this fuzzy cloud of probabilities, with multiple paths being explored at once, have we traded our ability to understand it for more power? We can't just read its thoughts step by step anymore. Its reasoning is getting more powerful for sure, but maybe also more alien. At the end of the day, Coconut represents a major step forward. It really suggests that the future of AI reasoning might not be about making machines think more like humans, but about allowing them to think in a way that is entirely their own, a way that's native to their silicon brains.
And that leaves us with this one last, kind of mind-blowing thought to chew on. By freeing AI from the limits of human language, we're essentially allowing it to develop its own native language of thought, a language of pure vectors. And the real question is, what kinds of ideas, what kinds of solutions, what kinds of discoveries will be possible in that language that are simply unthinkable in our own?